Hello, I'm Gwen. I'm presenting EDLE, Area Detected Liquid Handler Enabler for Transparent Liquid Reagents. My project advisors are Mihir and Qifei. Happy to present the EDLE system. First of all, what is EDLE? EDLE is a real-time computer vision system that measures transparent liquid volumes inside the pipette tips and in real time for both liquid handlers and for manual pipettes. So this is the pipette tips, and this is the manual pipette that can just get the pipette tips and do the pipetting that you would do in the high school for biochem experiments. And here is an example of the liquid handlers, which is a robot that can do the pipetting for you automatically once you program for it. Okay, so why I developed EDLE? Because first of all, almost no liquid handlers on the market or in the lab have a monitoring system that can tell you what exactly happened when it's running. So if you are away from the lab, it is really hard to know what exactly happened. If it's something wrong during the middle, you wouldn't know. And your samples, which have been working for like months or years, may be discarded just because of this. So we really need a monitoring system. But why transparent reagents? Because a lot of experiments in cell biology, proteomics, DNA origami projects, which I'm in right now, it has a lot of liquids that is transparent, and you wouldn't know. Like it's really hard to tell from even human eyes. And I wanted to make a system that can have the setting that can just know how much is it in the pipette tips. All right, so my contribution mainly in this project has two. One is I create a device, like this is a 3D printed box that costs $20 that you can put your pipette on. So this is a pipette holder. You can put the pipette on, and this is the device that you can just do the pipetting and then plug it in, and you will get the volume for each tip. And another one is the EDLE in Opentrons, which can detect it for you during the operations. And here's the detailed workflow. First, you asked a protocol from a scientist you might know, and then put it into the Opentron to run the experiments automatically. But during the process, our EDLE will be activated, and it will real-time monitoring how much volume in each tips during the operation, and does it have droplets? Droplets is the tiny bit, the like circle down the pipette tips, which might cause cross-contamination of your samples, and it was really bad. And if something wrong detected, like droplets or wrong volumes, it will just retry 3 times in the Opentron itself and send the warnings to users. Just want you to know earlier than the latest when you have to discard the samples. Okay, and this is the workflow. I won't go into details. I'm excited to show you a demo here. Okay. So I have a camera inside the 3D printed box, and this is the camera's view. Okay, now I'm gonna use the multi-pipette tips to just aspirate. I aspirate like 40. It's not really visible. I aspirate like 41 microliter. This is in microliter. So I'm gonna plug it in. It will show in real time. Look at this. So it is, with this illumination settings, it's pretty obvious about the liquid levels. It can successfully detect the bounding box of each tips and the volumes. Let's try a different volume, shall we? Okay, so if you remember how to use the pipettes in high school, maybe. Let's try 30, well, let's try 29. Okay. Okay, aspirate. Oh, it's pretty good. It's actually 27, 28. The middle one isn't really good. It's like too overexposed. And I've written in my future work. Okay. Now, it's the time for Opentron. Okay, here's the Opentron setup. I have two cameras, but the actual camera for detection is only one, the very little USB camera. And this is the view that will deploy the detection algorithm. This is just for your view, like what happened in that inside. Okay, and this is the control panel for Opentron. You can choose the parameters, like how much volume you want to pipette, and where a pipette from, and where a pipette to, and how many times you want to retry after detecting the volume error, and what is the delay time after you do the pipetting, just to keep the tip clean. Okay, let's run it. So now, okay, so you can see the pipette, the liquid handlers is grabbing the tips from the tip box, and then aspirate 10 microliters and go in front of the camera. And you can successfully detect the bounding box and the volume. Well, the volume is a little bit off because the lighting has changed a bit. Okay, so as you can see that the volume it detected is actually larger than what it should be. So it has volume error for each tips. Then it will do 3 times the retrying, and then dispense the volumes and then drop the tips. So that's one cycle. Okay. Yeah, that's pretty much it. Hope you'll enjoy it.